Sixth grade lesson 7.3 is writing algebraic expressions. And to get into this lesson, there's a couple of vocabulary words that are key to know. First, a variable. A variable, you've seen these already. You probably know what they stand for already. But anyway, that it's representative of an unknown value. It's represented by a letter or a symbol. Usually we use X. I like to use X because it doesn't really look like any numbers that I write. But it's usually represented by a letter, any letter, as long as you specify what it's standing for. So a variable is usually when you're seeing letters in math expressions, because they're representing an unknown value. We're not sure what it is, but it is a number. So X, Y, A, B, whatever. Those are variables. An algebraic expression. So we were looking at numerical expressions where there was all kinds of, it was a mathese sentence or mathematical phrase that had different operations that had to happen: add, subtract, multiply, divide, exponent. Well, an algebraic expression is the same thing. It's still an expression, but it will have at least one variable included in there, one unknown value represented by a letter in there. So some examples of what a algebraic expression might look like would be like x plus 10. That's an expression. There's addition between 10 and whatever x represents going on. Obviously, I can't solve it. I can't evaluate it because I don't know what x is yet. But as soon as somebody comes in and tells me, hey, by the way, x is this, then I can solve it, right? Or 3 plus y. It's an algebraic expression. You've got addition going on there. 3 added to whatever y is. We can't evaluate it again because we don't know what y is yet. But when somebody tells me, then I'll be able to do it. And another example, 3 times whatever a plus 4 will be, the sum of a and 4. That's an expression close to a numeric expression, right? If I knew what a was, if I had a number for a, then this would be a numeric expression. But because we still have an unknown value, a variable, then it's an algebraic expression. So that's what those are. And I always refer to these as mathese when we're taking word problems that are all in English, and then I translate them into mathese so that I can solve it once I find out more information. So that's what this lesson is about. We're going to take these word problems, and they're going to guide us through how to change that word problem into an expression so that when you do get that further information of what that unknown value is, then you can evaluate it. All right, so same steps when we're dealing with word problems as we've been doing all year long. Read it first, underline the question, circle the information they provided you, draw the picture, and then evaluate. Or in this case, if they're not asking us to evaluate or solve it, they're asking us to write the expression down, then that's what we're solving. We're writing the expression down. So let's read this first. An artist charges $5 for each person in a cartoon drawing. Write an algebraic expression for the cost in dollars for a drawing that includes P amount of people, unknown amount of people. They want me to write an algebraic expression in dollars for the drawing. Circle the information they gave us. We know that it is $5 for each person in a cartoon drawing. So draw the picture. I have one person is $5. Another person is $5. And on. I don't know how many people. So if I don't know how many people, I'm going to let the variable p represent people, the unknown value of people, which is what they did there. Usually you just choose the variable, the letter you want to use, and I always kind of just put it in a little mini sentence for my brain. I'm going to let p equal people. Okay, so the cost for each person we know is $2, right? I'm sorry, not $2, $5. $5, it says right there, $5. And I would multiply that by however many people I have. $5 for every person, $5 for one person, $5 for another person, $5 again, $5 again. It's a repeated addition, multiplication, right? So the expression I would write is 5 times p. Now, here's my chance to let you know, and I think at this top of the same page that we're looking at, where it says math idea, it talks about this too. More often, as you get further into math, rather than writing 5 times the variable or a number times the variable, most of the time you'll see it written this way, 5p. it's assumed if you have this number right next to the letter, it's assumed that you're multiplying those together. So that can be written, 5 times p can be written as 5p. It can be written as 5 times p. It can be written as 5 times p. But most often, as you go further in math, you are going to see 5 times p written this way, 5p. And your brain will adapt to that fairly quickly, 5p. So this here could be written as that answer. This is a correct answer too, so no worries. Okay, and same steps again. Read it, underline the question, circle the information provided, draw it so your brain can understand what's happening, and then go ahead and solve. So on Mondays, a bakery adds 2 extra muffins for free with every muffin order. Write an algebraic expression for the number of muffins customers will receive on Mondays when they order M amount of muffins. Okay, they want me to write an algebraic expression for the number of muffins the customer will receive on Mondays, the special deal day, when they order. We don't know how many muffins they're going to order, right? We know that they get 2 extra muffins for every order, for every muffin order. I don't know how many muffins are going to be in that order, but let's go ahead and draw a picture. Let's just call this picture of a muffin. Pretend that's a picture of a muffin. Let's call this picture of a muffin the muffin order. We don't know how many they're ordering in that order, but if they order that, they get 2 extra muffins, right? So whatever that muffin order is, we don't know what it is, how many are in that. So let's let M equal the amount of muffins in that order. So we know that whatever the amount of muffins are, the muffins ordered, we will add that to the 2 additional muffins that they will get as the special Monday deal. So customers will receive muffins plus 2. And that's just written that way. It doesn't have that like the previous one where you put it together a different way. It's just addition, 2 terms added to each other. So that is the answer to that. We can't solve it any further right now. We can't solve this question any further right now until somebody comes along and says, psst, by the way, they ordered this many muffins, and then we can plug that answer in and go. But for now, that's as far as we can get. But wouldn't that be nice to have that narrowed down into our mathese sort of expression, into math language, rather than in this long English language, so that when they do come forward and say, okay, the amount of muffins ordered is this, then we're not having to go back and read it and do all the steps again. We're just like, oh, amount of muffins is this. Okay, plug that in and solve it. So we just translated it to be ready for when they tell us how many muffins. Okay, more practice. Practice is good. Example 1, this is page 270. The table at the right shows the number of points that items on a quiz are worth. Write an algebraic expression for the quiz score of a student who gets M multiple choice items and S short answer items correct. So we're writing an expression for how many points these students get on their test. And here's the information we're provided. They get 2 points for every multiple choice answer they get correct, and they get 5 points for every short answer response. Let me draw that. I have multiple choice, 2 points. And then I would add that to any of my short answers, which are 5 points each. These are each. So if I have 1 multiple choice correct, I get 2 points. If I have 2, then I have another 2 points. If I get another one, it's another 2 points. That's repeated addition, right? So it's going to be 2 times whatever multiple choice. Let's let M equal multiple choice. So 2 times M, also known as 2M, which is what they put here. 2 points for multiple choice items, added to the points for the short answer items. Well, it's 5 for each one. 5 for one, then 5 for another one, then 5 for another one. That is repeated addition, which is multiplication. Let's let S equal short answer. 5 times S, also 5S. and that's being added together. So my expression can be 2m plus 5s. It could be written 2 times m plus 5 times s if you're just not comfortable yet with these terms being written that way. It can be written out. That's okay too. That's the same answer, same equation. You just will take a little bit of time to get your brain adjusted to that. You could probably notice why I tend to avoid using s's as my variables. Remember, you can choose what over here, right? We chose that s equals short answer response. I could have put x instead, and usually I probably would have, because as I get writing my math real fast, a lot of times my 5s end up looking like my s's, and then I get confused. So keep an eye out for that as you're doing your math. If you know that your s's look like 5s, then change that s to a different variable, change it to a different letter that doesn't look like your numbers as much. So I could have put 2m plus 5x instead, and still it's an unknown number, so I'd still be good. Okay, and finally they just have us just practicing, not in word problem form, just in English form into Math Ease and how this looks, and this just takes a little bit of practice too. They want us to write in Math Ease, in an algebraic expression, 30 more than the product of 4 and x. So here's something that's super useful for this sort of thing. Okay, and I just Googled, operation words, math operation words or something like that. And I got all kinds of images like that. These are addition words, subtraction words, multiplication words, division words. This helps with this sort of thing in the event that you don't have these memorized. So we have 30 more than the product of 4 and x. So I want the product of 4 and x. Product, if you didn't recognize right away, is a multiplication word, and it is the answer to a multiplication problem. So the product of 4 and x is 4 times x, which I could write as 4x, right? And they did that right there. And then we want 30 more than that addition word. So we're adding 30 to 4x. There's your expression translated from English to Mathese. What about the next one? We have 4 times the sum of x and 30. I'm going to do the sum of first because sum is the answer to an addition problem. So it has to be done first, x and 30. The sum of x plus 30. And all of that together is going to be multiplied by 4. Times is a multiply, so 4 times the sum, 4 times the sum of x plus 30. The reason they put parentheses around there, and they do need to put parentheses here, this is very important, is because if I wrote it this way, then order of operations says that multiply must happen before addition. Well, this expression is saying I want the sum of that to happen first. Well, how can I bump addition above multiplication on our list? Remember our checklist? How do I bump addition above multiplication? Well, put parentheses around it, and then it gets bumped to the top. If it said it wants the sum to be multiplied, the answer to the addition problem to be multiplied by 4, then I've got to make sure the addition happens first to get the answer to the addition problem first. Bump it up my list by putting parentheses around it, and now it will come first. So something to watch out for in this lesson. Good luck with this one. Work with a study buddy to compare your answers with some people. You're going to mess a few up. It's okay. Just keep working on it and fixing it and learning from your mistakes.